Hey guys, hello everyone. So now in today's video, let us discuss about the next topic of Unit 1, vector analysis, divergence of vector field. So first, definition, right? Now, if we take any parallel pipe in such a way, from left side, the flux lines enters. Let us place this parallel pipe in a vector field, right, of magnitude A, right? Let us, A be the vector field, right? Let us place this parallel pipe in a vector field. So now from the left end, these flux lines enter into the parallel pipe, and from right end, the flux lines leaves the parallel pipe, right? From the right end, it leaves the parallel pipe. Let C be the center of parallel pipe, right? Now, if we consider this any particular point in parallel pipe, then the flux lines leading from that point per unit volume of a parallel pipe, we take as divergence of a vector field, right? We take as divergence of a vector field. So what is the divergence of vector field? The amount of flux lines per unit volume diverging from a point is defined as divergence of a vector field. It is defined as divergence of a vector field. And this is written as either div A or del dot A. Right? So, this is equal to, how we will write? Del means I dou by dou x plus j dou by dou y plus k dou by dou z dot. We can say the dot product of del operator and vector A. The dot product of del operator and vector A. Mathematically, physically, the amount of flux lines per unit volume diverging from a point. Right? Now, A. If AX, AY, AZ are components of A along X, Y, Z directions of coordinate system, then we can write A as I, AX plus J, AY plus K, AZ. Now dot product, I dot I 1, I dot J 0, right? Now only I said the property of this dot scalar product, right? So now writing that I dot I dou AX by dou X plus again dou J dot J dou AY by dou Y plus again K dot K dou AZ by dou Z. So this is the divergence of vector field, right? Now, let us go for the derivation of this divergence A, right? Divergence of vector field, right? So now, to derive the expression for divergence of vector field, what we must derive? Dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z we have to derive. So for that, consider a parallel pipe. right? In such a way that its sides are parallel to x, y and z directions, z axes. Now let the length of side parallel to the x-axis be dx, that parallel to the y-axis be dy, and the length of side of a parallel pipe parallel to the z-axis be dz, right? Let C be the center of a parallel pipe. Next, let EF GH the left face of the parallel pipe, PQ RS the right face of a parallel pipe. Now, the flux lines enters from the left face and the flux lines leaves the parallel pipe from the right face, right? Now, consider a midpoint N in left face, M in a right face, M in a right face, right? Now, let A be the value of velocity of flux lines or fluid at center C. The velocity of fluid or flux lines flowing at center C. Now, resolve A into components along x, y, z axes. The component of A along x-axis is AX, along y-axis AY, along z-axis, right, AZ. Okay. Now, first, the rate of change of AX along x-axis. How we will write? Dou AX with respect to x-axis. So, dou X. Similarly, rate of change of AY along y-axis. Dou AY with respect to y-axis. So, dou Y. Rate of change of AZ along z-axis. That is equal to dou AZ by dou Z. Right? Dou AZ by dou Z. Clear? Now, first, let us write the value of AX at the center. Okay? So, first, let us write the value of AX at the center M. First, let us write about this right face, then let us go for the left face. Right? So, the value of AX at the center M of PQRS face will be equal to the value of AX at center C plus the increase of magnitude. From center we are considering, so C to M, right? So what will be the value of AX at center? AX itself only. AX itself only. Now the increase of magnitude of this flux lines from C to M, how we will write? Rate of increase into distance. right? Now next, what is the rate of increase? Here we don't know. Dou AX by dou X. Now what will be the distance? The total length of the side of parallel pipe parallel to the x-axis we said dx. But from center we are considering. So from center the distance becomes dx by 2. Alright. 1 we got. Similarly, the value of AX at center N of EFGH phase. This will be AX, same procedure, minus dou AX by dou X, dx by 2. Why we not negative sign? 2, because N is towards the left of C, right? N is towards the left of C. So only we wrote minus, right? Now we wrote the AX value at the center M and N of both faces, the left and right faces. Now let us write the value of flux. Now what is the definition of flux? Here I am writing. Flux is denoted by pi. The component of vector field and the area of that particular vector field we define as flux. Alright. So now first let us write the flux entering through left face. Flux entering through left face. What will we write? The value of AX, A. What is the value of this AX? Along X direction I am writing. Along X direction. Right? So the value of A becomes along X direction. AX minus dou AX by dou X dx by 2 into what will be the area? Area will be dx dy dz. What is dy dz? Area. Okay. So area. Now next, similarly flux entering through, leaving flux, leaving through right face along x direction, leaving what we wrote, MO. So AX plus dou AX by dou X dx by 2 and area is dy dz, right? Here the value of the AX is AX plus dou AX by dou X dx by 2 and here the value of AX is AX minus 1 by 2 dou AX by dou X dx, right? Now next, net flux leaving from the parallel pipe along x-axis, right? What we will write? AX plus dou, I will write it as 1 by 2 dou AX by dou X dx dy dz minus AX minus 1 by 2 dou AX by dou X dx dy dz. This minus this. The net flux along x-axis. This minus this. Now dy dz let us take as common. We get AX plus 1 by 2 dou AX by dou X dx minus AX minus plus dou 1 by 2 dou ax by dou x dx. Common I took dy dz. Right? Now ax strikes off. This plus this. 2 of dou ax. 2 of 1 by 2 dou ax by dou x dx dy dz. Now 2 strikes off. Right? So the net flux leaving parallel pipe along x-axis is equal to dou ax by dou x. Now here dx is there and here dy dz. Right? Similarly, along y-axis, dou ay by dou y dx dy dz. Similarly, along z-axis, dou az by dou z dx dy dz. Right? Now next, the net total flux leaving parallel pipe. How we will write? Dou ax by dou x dx dy dz plus dou ay by dou y dx dy dz plus dou az by dou z dx dy dz, or dou ax by dou x plus dou ay by dou y plus dou az by dou z dx dy dz. Right? Now next, flux flowing per unit volume. How we will write? Dou ax by dou x plus dou ay by dou y plus dou az by dou z dx dy dz. And what is the volume of parallel pipe? Dx dy dz. Alright? So this flux flowing per unit volume, we call it as divergence of vector field. So divergence of vector field is dou ax by dou x plus dou ay by dou y plus dou az by dou z. Right? This is the derivation of divergence of a vector field. So I'm providing the notes also along these videos. So you will find the notes link in the description of my video. Thank you for watching. Yours, Reshma.